In this video here, we're going to learn how to solve questions related to trapezoidal rules. So we're going to use example 2 in our lecture notes as reference. So in these questions here, they ask us to find an approximate value for the integral ln x integrate with respect to x from 1 until 8 by using trapezoidal rules with 4 ordinands, and give the answer correct to 4 decimal places. So, based on this info here, by the time they're asking for 4 ordinands, that means later in the table that we're going to construct for trapezoidal rules, we're going to have 4 x values, and this will corresponding to, we are going to use 3 strips of trapezium to do the calculation, which I refer to n equals to 3. And by applying trapezoidal rules, the things that I need to get ready is that I need to find out what is the corresponding value of h, where h is referred to the upper bound of the integrate minus the lower bound of the integrate divided by the number of strips of the trapezium that we're going to use. In this case here, we have identified that we are going to make use of n equals to 3, the a and b corresponding to the 1 and 8 in the integral, and therefore from there I have n equals to 3, h by calculation I have 8 minus 1 over 3, and then the result is 7 over 3. Once I get this framework here done to find the h, now let us try to construct a table to help us to solve the question by using trapezoidal rules. So the construction of table, I will suggest that you do something like this, where we have 3 columns, but the 2 columns behind here is happen to be share the same title, where I have y equals to ln x, and this is actually referred to the functions in the integral. The functions in the integral. The x value is corresponding to the variable that we do integrations. And for the columns for the x value, what we're going to fill in here is that we're going to refer to the boundary, the lower bound as the start, the upper bound as the end. So we will begin with the first value here in the x value here in the table with 1, which is the lower bound of the integral, followed by the next value, where I'm going to have the next value happens in the way that I add up with the value of h that I have evaluated, which is 7 over 3. So as a result, what I have the next is that I have 10 over 3. Then the next one, add another 7 over 3. Add another 7 over 3. By right, I have the final value of x here is referred back to the upper bound. And in order to make sure that you can get back the upper bound value here in the calculation for the x in the table, I will suggest that you don't convert this h value into decimal. We use fractions here for exact value. Then when the time we come to the calculations for y, what we happens to do is that we're going to make use of calculator, and before we go on further with the calculation, I want you to observe something here. You find out that I have 2 columns for this y here, where the shaded part is referred to the part that we're not going to fill in anything. And we're going to separate the column in the way that the first and the last value for the x, we happen to add the same column, then the rest in the middle in another column. This is for the reason that later it will be easier for us to do some for further calculations. Go on. Now it's time to make use of our calculator to get the answer fast and efficient. So in this case here, we're going to use a built-in function in our calculator, where we go for the mode, we look for the functions of table. Different calculator, maybe they have different command on pressing. So anyway, we're going to look for table. So option 7. Then it will come out fx equal So this fx equal here, we are going to refer to the x functions that the x function that we have in here, which is corresponding to the function inside the integral. So we insert ln x. Next, we press equal. You will see another function g appear because our calculator is able to do the calculations for two functions at the same time for table. So for the second function gx, we just ignore it. We just continue press equal, and then it will come to the lower bound value. In here, my calculator display as start, so I want to start from the lowest value 1. So I insert 1 equal, and the upper bound value, I want to end with 8. I press 8 equal. Step is referred to the h value. So in here, my h value is 7 over 3. So let me insert 7 over 3 equal. Then you will see that a table is constructed now. And we're just going to copy the value from the table in the calculator into our table here. And by the way, just for information, for the x column in our calculator, they may not able to display to you the fraction form on the table, but you can happen to view the fraction value. If let's say the fraction doesn't come with a denominator that is too large, then we can press the button SD here to find out the corresponding fraction should have. And you can check one by one back to your x value. And anyway, I want to more focus on the y value. So we start with the first y value. I will happen to find out that the first y value, when the time I substitute into the function, I got 0. The next y value in here, I'm not going to copy the full decimal here inside, but I need to refer to the question. How many decimal places that I need for the final answer? So if I need 4 decimal places for the final answer, so in my calculation in the table, I'm going to put in 5 decimal places. So refer to this answer here, 1.2039. There's more decimal behind there that I need to refer. So refer to this value here. If I round off to 5 decimal places, but I have 1.20397. So we copy down the result. And one thing I want you to be aware, in case if let's say you need only 4 decimal places along the calculations, don't you just refer to the calculator here, the table here, and then just directly copy. Where you can see the display on the table here, they doesn't round off the value for you. By right, if you refer to the actual value down here, 397, I should round off become 40, but the display still remain as 39. So be careful on that. The table display doesn't happen to be round off for you, so you need to check by yourself one by one. Then the next value, so I have 1.73460. Then last value, I have 2.07944, up to 5 decimal places. So the built-in function, it will happen to help us to find out the value on top here only. Then for the total, I'm afraid we need to do it manually by yourself. So we click the mode of table back to compute for the answer. So 0 plus 2 point something, I believe you don't have to press calculator. We know the result is 2.07944. On the other one, maybe you can press your calculator. In here, I'm not going to show you the way of pressing. You just manually key in this two number here, add up. So I will have the answer as follow. Once I get this result here, then I apply Newton-Raphson formula to solve the questions. Whereby Newton-Raphson formula, I will have start with this integral will approximately equals to h over 2. Our h here is 7 over 3. So 7 over 3 divided by 2, it becomes 7 over 3 times 2 at the bottom. Multiply with, inside the brackets here, we're going to have 2.07944, which is the sum of the first and last value, plus with 2 times of the sum of the middle value. Then once again, this whole thing here, you're going to press the calculator manually and keep your answer up to 4 decimal places. In table, in the substitution here, we have 1 extra decimal places compared to the final answer. So therefore, our final answer, by right, I have 9.2827 up to 4 decimal places. Next, there is extra information that I would like to discuss here, which is referred to what we call as the error. As we know that trapezoidal rules is happen to be an approximation to solve integrations. So this approximation is not the actual value, it's not the exact value. So somehow it may have some difference from the actual value, and the difference is happen to be what we call as the error. And let's see the idea of error here. By using the integration technique, by using integration by parts, I find out that integrate from 1 to 8 for ln x by calculation is supposed to equals to actual value 8 ln 8 minus 7, or we round off to 4 decimal places as 9.6355. So how it happens to calculate error is that we make use of the formula. Error is the modulus of actual value minus the approximated value. So the actual value is the integration value. Approximation value is happen to be the trapezoidal rules value. So although the formula happens to write in this way, but just for simple understanding is that you just need to consider the approximate value and the exact value. Which one happen to be larger? You just take the larger one minus the smaller one will do. The modulus is just happen to write the formula in general. So as a result, we take the larger value, 9.6355, the exact value, the actual value, minus the approximation value, 9.2827. Therefore, the error will be 0.3528. This is how we happen to get the answer.